Hi, I'm Paul. This is Science That Sticks, Ionic compounds. Roll the graphic. Hi, I'm Paul. This is Science That Sticks. Today I'm looking at ionic compounds. Everything you need to know about ionic compounds. Now, the thing about ionic compounds is that you need to know that they start with elements or atoms that have either gained electrons or lost electrons. Once an atom has lost or gained an electron, it becomes an ion. If it gains one electron or more than one electrons, then it becomes negatively charged. If it loses electrons, then it becomes positively charged. The negative charged ions are called anions. The positively charged ions are called cations. Let's check out this. An atom of lithium can react with an atom of fluorine. As it reacts, you won't see because you can't see electrons, but one electron in the outer shell of lithium gets transferred to the outer shell of fluorine. Now, I've drawn the inner shell and the outer shell for a good reason. That good reason is for you to see what electrons are involved in bonding and which ones are not. Also, because this has two shells, it's in period 2. Because it has one electron in its outer shell, it's in group 1. So we can use electronic structure to describe where the electrons are. And also we can use the periodic table to describe where the electrons are. Pretty easy stuff. Now, if this moves from here to there, the lithium becomes a positive charge because it's lost one electron. It has one more proton than electrons that it previously had. The number of protons doesn't change, by the way, but the number of electrons does. Therefore, it becomes Li plus 1. The fluorine atom becomes a fluoride ion, and it's really, really stable. Now then, as you can see, the lithium and the fluorine react. It produces lithium fluoride. Now, my drawing's not brilliant, but your drawings in science examinations do not need to be excellent or accurate. They just need to show what they need to show. Most of the time, the inner orbitals are not required, but this shows everything it needs to, and a bit more. If we were to write it as a word equation, it would be lithium plus fluorine, arrow, lithium fluoride. If we write it as a chemical equation, we will need to balance it. Balancing chemical equations is another video. Let's look at both of those. Ta-da! Now, notice that the lithium plus fluorine makes lithium fluoride. That looks like a U there, so we'll just change that more so it looks like an N. There we go. The balanced chemical equation, Li, which is a solid at room temperature and pressure, reacts with fluorine gas, which happens to be a very dangerous gas, but it's still a gas, and exists as F2. Because it exists as F2, we've got to balance it up. So 2 atoms of this are required with 1 molecule of that to form 2 molecules of LiF. Because I'm using the word molecule and people are going to get confused with, well, he must mean simple covalent molecules. No, I'm just talking about molecules here in terms of what you can see and picture up here. The reality of this is that lithium chloride forms a giant ionic lattice. This means that there are oppositely charged ions that are electrostatically attracted to one another. These require a huge amount of energy to overcome, which is why they have very high boiling points, very high melting points. That's ionic structure or other ionic bonding. Till next time, stay cool. Goodbye.